Hello everyone. Today we are going to see the next topic of unit number 4. The name of unit is Association Rule and Mining, and we are going to cover the topic name, that is frequent item set and the closed item set. Previously we have seen the topic, that is market analysis, from the same unit, that Association Rules Mining. So what are the terms that frequent we are using, what the item sets that are called as a frequent, what item sets and they are called as a closed, how they are called as a maximum, that thing we are going to learn today in this session. So moving forward, these are the contents that which we are going to cover here, and with this content we will start with the frequent item set. So what is the frequent item sets? Let's see. The set of items that we are collected, that is called as an item set. So different items that when we are togethering, we are combining, that set is called as an item set. So this is what the one term from your frequent item set. What is the item set? It is nothing but sets or a collection of items, that is called as an item set. The item set which appears frequently in our transaction data set are called as a frequent item set. So whatever the data we have to analyze for finding out the frequent patterns, or for a mining purpose, or for a market basket analysis, any particular thing, or if we can say for the association rules, then at that time whatever the transaction data set we are using, we will find out in that transaction data set that which item sets which going to appear frequently. First of all, if we are going to check a single item whether that item is frequently appearing or not, then we are just checking a single item in that transaction data set, whether the how many times that items are occurring. But if you want to check the set of item, for example, if we are considering the butter and bread, if this is what the combination, that item set is contain two items, butter and bread, and according to that two items, how many times this combined set comes, means bread and butter, how many times this bread and butter comes in a transaction data set, that we are going to check here. So here we are going to term it as a frequency, or a support count, or a count. So these are the different terms that we are going to use when we are counting the frequent item set. So either you can say the frequency of that item set, or a support count, or you can say just count of item sets. It's a number of transaction that contains item, means in how many transaction the item set appears. That count, that number of transactions are nothing but a frequency, or a support count, or a support of item set, or a count of item set. So an item set, if I am assuming that I want to calculate the frequent item set of name X, so item set X is a frequent if its support is no less than a minimum support threshold. Means its support number, whatever the support number we have calculated for that X, its support number should be less than a minimum support threshold. So we are going to see these terms also here. Its support should not less than of minimum support, means it should be a greater than of your whatever the value we are finding out, that support number or frequent count, that count number should be a greater than minimum support threshold. So this is all we are checking about the frequent item set. But when we are going to term it as a frequent, or a closed, or a maximal, so for that we are going to learn one by one term right now. So item set that contains the K item. For example, if I am saying the item set is milk, bread and butter, so these are the three things. So I will say 3K is nothing but 3 items we are having. So 3 item set, we will call it as a 3 item set, 2 item set likewise. So the item set that contains K items is called as a K item set. For example, the set mobile and SIM card is a 2 item set, because there are only 2 entities we are having for a particular item set, mobile and SIM card. So that's why K is having value 2, and I will call it as a 2 item set. If support of a item set is greater than or equal to the minimum support, then it is called as a frequent item set. So the minimum support is given. If we are solving any example, then they mention the minimum support, and according to the minimum support we are going to say if a particular item set we have choose then that chosen item set is having its count greater than the minimum support, then I will say that this item set is a frequent item set. Then I will say the item set is a frequent item set. So an item set is a closed if none of its intermediate supersets has the same support as an item set. What are the supersets and subsets? Subset means if x, y, z are the 3 items in my set, then xy will be the subset of that item set. Okay, xy will be the subset of that item set xy, z. This is called as a subset. What is the superset? If I am saying xy is my item set, then what will be the superset of that item? xyz means xy is belongs or it is a subset of that xyz. So here xy is called as a subset, xyz is called as a superset. Okay, so this is the term subset and superset. The subset will belongs to the superset. So whenever a item set, if we want to say that my item set is a closed, then when we can say it is closed? If none of its immediate superset has the same support as the item set. Means what? For this item set, I want to calculate the whether they are closed item set or not. Then its immediate supersets, whatever the superset we are having for that item set, that has the same support of that item set. If its item sets and superset support count will be same, then we can say that the item set is a closed item set. It is in simple term, if the support count of this item set is equal to the support count of its immediate superset, then we can say that a particular item set is called as a closed item set. In terms of x and y, if you want to know, an item set x is a closed in the data set D. What data set I am saying? My data set, its name is D. And if I am saying the item set x, whatever I have chosen, is closed in my data set D if there exists no proper super item set y such that there exists no proper super item set y such that y has the same support count as a x in a D. Means none of its immediate superstar. There should not be any single superset that superset will have the same count as a item set. Means if a count of superset is not matching with their subset, then we can say that that item set is a closed item set. There should not be any proper matching between that super item set such that they are having the same count as their subset. This is what the concept. If we are going to see this concept by example, then you will come to know more about that. So an item set X is a closed frequent item set if the terms before we have seen is closed only. Now I am saying about the closed frequent, means it is the combination of both frequent and closed. So the item set X is said to be the closed frequent item set in set D if X is both closed as well as the frequent. When it is going to be frequent, if it is having its count more than the minimum support. If a support count of the item set X is greater than the minimum support, then that item will be a frequent. And when it is said to be closed, when none of its supersets will have the same support count as like X. Then and then X will be called as a closed frequent item sets. And item set X is a maximal frequent item set. Now the new term is there, maximal item set. Max item set, or you can say the maximal frequent item set. So X will be said as a maximal frequent item set in a data set D, that we have actually assumed that my data set is D. Then if the X is a frequent, see the term, if X is a frequent means it should be frequent and there exists no super item set Y such that X will belong X is subset of Y and Y is a frequent in D. So if we want to know in a simple terms, then how we are going to define this two definition in some simple terms. See here, the maximal item sets are nothing but an item set is a maximal frequent if none of its supersets are frequent. Means if the supersets of that current item set is not a frequent, then I will say that my item set is a maximal item set. And when it is called as a closed, when an item set is a closed if none of its immediate supersets are same support count as a item set. Means if their support counts are not same, if none of its supersets, if a single item set is having 3 supersets, for example AB is having its superset as a ABC, ABD, ABE. Okay, for a AB set its 3 supersets are ABC, ABD and ABE. So if both of the 3 sets is not having the same support count as our AB, then we can say that the AB is closed. Okay, then we can say that AB is closed item set. And maximal is when none of its superset are frequent. Means I am saying AB is my item set, AB is my item set and it should be frequent. It should be frequent. When it will be frequent? When its support count will be the maximum or greater than or equal to the minimum support, then it will be frequent. So your AB should be frequent, and whatever its superset, if I am saying ABC, ABD and ABE, these are the 3 supersets of AB, then not any supersets of them, none of that, these 3 supersets, they should be frequent. Means ABC should not be frequent, then ABD should not be frequent and ABE should not be frequent. Then and then you can say that my item set is a maximal. So this is what in a simple terms. To make it more simple, we are going to see the example on it. So here in this diagram you will come to know what I want to actually say, that the lattice diagram is drawn over here. We are going to find out the maximal, closed and frequent item sets here in this lattice diagram. So you can see the circles are colored with the different color over here. So whatever the circle colored with the blue, they are a frequent item set. So how they are a frequent? First we will understand this diagram and then we'll move towards the color choices and what are the different color means. Okay, so see, the items are, the basic single items we are having is A, B, C and D. So in my frequent data set or in my transaction data set, A occurs thrice, B occurs twice, C occurs thrice, again D occurs twice. So these are what the frequent count I have written over here. Now whenever I want to find out the superset of A, means A should belong to some set. So A is belonging to AB, right? A belongs to AB, A is a subset, AB is a superset. Again I am repeating, if A belongs to AB or A is a subset of AB, then A is called as a subset and AB is called as a superset. Okay, so whatever in the next level we are finding out, they all are the superset of this subset. So I will say the ABCD are subset and whatever we have mentioned in this level, they are a superset of this subsets. So see here, the A is from A's supersets are AB, AC and AD. These are the supersets of A, AB, AC and AD. Okay, these are the supersets. Then don't look out at a color first. I will just show you first how the level or hierarchies are met and then we will move towards the color. So if I am considering the B as a subset, then what can be the superset of B? The set which containing the B. So which are the sets? If you are saying AB, AC is not containing any B, so it will not be a superset. Then AD is also not containing B, so it will be not a superset. Then next is BC, yes, it contains B, so BC will be the superset of B. Then BD will be the superset and the CD is not going to be superset because there is missing value B, right? Then for a C, the supersets are AB, no. AC, yes, it is a superset. AD, not. BC, yes, it is a superset. And BD, no, because it is not containing C, and CD. So if you are saying this lines, which are coming from a subset to the superset, then they are choosing a superset, whether they are 3 or 4 depends. So for a D there are only 2 supersets, AD and BD. So in this way we have finded out the superset. So what I will call it as these sets are containing a single item, so one frequent, this is called as a 2 frequent because there are 2 values at a time, and if I am combining the 3 values at a time, then I will call it as a 3 frequent. So what is the 3 frequent? ABC, ABD, ACD, BCD, these are the 3 frequent. So I will check. AB is a subset of ABC, it is a subset of ABD, it is the subset of only 2, ABC and ABD. Same way, AC is a subset of ABC, yes, because AC occurs in the ABC, so that's why AC is a subset of ABC, ABC is a superset of AC. Again, AC is a subset of ACD, okay, because here also AC occurs. Same way, AD is a subset of ABD and ACD. Same way, BC is a subset of ABC and BCD. So likewise, we have found out all the subset and superset. And after the 4 frequent, for the 4 frequent, if you are looking over here, then ABC is a subset of ABCD, definitely. ABD is a subset of ABCD, definitely. ACD is a subset of ABCD, definitely, and the BCD is also the subset of ABCD. So in this way we have prepared this lattice diagram. Now I am going to find out the frequent item set. So how I will come to know that my item sets are frequent or not? So for that, what we are checking, that they should have a minimum support count, okay. If your frequent item set, whatever the frequency count, that frequency count of particular item should be greater than the minimum support. So now if I am assuming that a minimum support count is 2, okay, it should be greater than or equal to minimum support count. If I am assuming the minimum support count is as a 2, here we have mentioned that thing. Yeah, if a support of item set is greater than or equal to minimum support, then it is called as a frequent item set. So we will see here, if I am assuming the minimum support count will be 2, then I will check the frequency of this. So A is having frequency count 3, yes, 3 is greater than the minimum support, that is 2, so I will mark it as a blue color, okay. I am just saying about the blue color, not the thickness. If you are looking at this, some of the circles are not thick and some of the circles are very thick. So I am not talking about the thickness, I am just talking about the color, that is blue color. So here 3 is having the is greater than the minimum support, that is 2. So that's why I make this circle as a blue. Yes, the item A is a frequent because its value is greater than the minimum support. Same for a B, 2 is not a greater than, but it is equal to the minimum support, that is 2. So I have marked it as a blue. Again C comes thrice, so 3 is greater than 2. Again I am marking it as a blue circle. Again D, it comes twice, it is equal to the minimum support count, and that's why I have marked it as a blue. Again in the next line, for the next, that is 2 frequent level, for a 2 frequent level we are going to calculate same thing. Now for AB, what is the frequent count? 2. What is the support count? 2. Whether this 2 is greater than or equal to minimum support? Yes, 2 is equal to 2, and that's why we have marked it as a AB. Now here AC is having a 1 as its frequency count, and 1 is not greater than or equal to our minimum support, that is 2, and that's why we have not marked it as a blue. Same way this 2 is equal to 2, so mark it as a blue. 1 is not greater than or equal to 2, so don't mark it as a blue. Then for this BD, this 2 is greater than or equal to, it is equal to the support, minimum supports, so I have marked it as a blue. Same for a CD, it is having value 2, so I have marked it as a blue. For ABC, ACD and BCD, both are having their support count less, so don't mark it. And again for ABD, it is having its support count as a 2, so mark it, okay. So whenever we have made the connection over here, Okay, whenever we are make the connection, so here blue circles are called as a frequent item set, means we can say it as a frequent. Why? Because their support count is greater than the minimum support. So I have marked all the frequent item set. What is the next thing I have to do? The item sets that are circled with the thick blue are a closed frequent. Circle with the thick blue, that are the closed frequent. Now what is the thick blue? A, C, CD and ABD, they are marked with the thick blue border, right? So they are called as a closed frequent. So what is the definition of a closed frequent? If we are revising the definition, closed frequent means an item set is said to be closed frequent if its none of immediate supersets have the same support count as the item sets. Immediate supersets. So what are the immediate supersets of A? Immediate, okay, immediate supersets are this sets. A is a subset. So what is the supersets of A? AB, AC and AD. Okay, so if none of its immediate superset, none of, keep I am stressing, give the more stress on this word none, because no superset should be there that should have its value greater than or equal to this A. So you can see AB is also having value 2. None of its superset, which are its superset? AB, AC and AD. So none of its superset is having its value equal to 3, and that's why we are saying A is a closed item set. Why closed? Because no one of its supersets is having its value equal to same as the value of A. It is having 2, 1 and 2. No one superset is having its value as a 3, and that's why we can say that A is my closed item set. If you think about B, then B is having AB, BC and BD. Okay, what is the support count of B? 2. AB is having value 2. Yes, they are matching. So I can't say that B is a closed figure because its superset is having same count as its subset. Okay, so we are not considering the B as a closed. Same for a BC. Yes, BC is not having, but another BD is having its support count. So no one should be superset should be there that will have the same matching of their support count. Okay, if I consider the C, then what are the superset of C? AC, BC and CD. Now I will check whether all the supersets are less than its support count. AC, yes, it is 1, not matching with 3. Then BC, it is having the count 1, not matched with 3, and CD is having count 2, not matched 3. Yes, for the item set C, none of its superset is having the support count same as the C. So that's why I will call as C as a closed figure. So I will say C is my closed item set. Okay. Now for we are directly moved towards the CD because they are marked as a dark. So what this CD is? CD is having its superset like ACD and BCD. So you can see no support count of their supersets are matching with the support count of our item set. Okay, so that's why I will say that CD is also my closed item set. If I am talking about the ABD, then ABD is having its support count as a 2. And if I am comparing it with its superset, then again it is not matching, and in that way, because if their super count is not mentioned, means they are not occur at a single time also, means their support count is 0. So again 0 is not equal to 2, and that's why we can mark it as a ABD is my closed item set. So in this way we have represented this closed frequent item set with the thick blue circle. Now the item set that are circled with the thick blue and have the yellow fill, they are called as a maximal frequent item set. Now these are the thick blue circles. Okay, these are the thick blue circles, but they have the yellow fill, means they are filled with the yellow color. They are called on the maximal frequent item set. So what is the definition of maximal frequent item set? That an item set is said to be the maximal frequent if none of its supersets are frequent. If none of its supersets are frequent, means the superset should not be frequent, then and then we can call it as only as a maximum. Okay, so if I am considering this thick blue, okay, A. So if you are saying that AB and AC, what are the supersets of A? AB, AC, AD. How many supersets from this is frequent? Whatever the color with blue, they are frequent. So AB is frequent, AD is frequent. So A cannot be a maximal because its two supersets are already frequent. If I am talking about B, then you can see for this B, actually there is no need to check this frequent set. If you are just checking the closed frequent, that is also sufficient. No need to check this frequent. So I will directly move towards the C. For C, I will check AC, AB, CD. AC and BC are not frequent, but CD is frequent, and that's why we can't say that C subset is a maximal. We can't say. If I am talking about the CD, if you check the CD, yes, ACD and BCD both are not frequent because they are not marked with the color. They both are not frequent, means all the superset of CD are not frequent, and that's why I will say that CD is a maximal superset, maximal item set. Okay, so that's why I will say that this is what the maximal frequent item set. Same about ABD. What are the superset of ABD? ABD only the ABCD. And is the ABCD frequent? No, because it is not marked with the blue color, and it is having their frequency count as a 0. So that's why I can say that the two that is ABD is a maximal frequent item set. Okay. So what I want to again repeat is that if any particular set is having 3 subset, so all three superset, then all 3 supersets should not be a frequent. If 2 are frequent and 1 is not frequent, then also you can't say that the subset is a maximal frequent. All 3 should not be frequent. Then and then you can say that the item sets are frequent. For example, if we are considering AB, for A is having the 3 sets. From 3, 2 are frequent, 1 is not frequent. Still A is not a maximal frequent item set. But if you think about CD, they are having only 2 supersets, and both the supersets are not frequent. Both the supersets are not frequent, and that's why we are calling the CD as our maximal frequent item set. So this is all about the maximal frequent item set. In order to determine which is of the frequent item sets are closed, all you have to do check to see if they have the same support as their supersets. If they do, they are not closed. So this is all about the closed and the maximal. So here in this example, you can see that the ABD, if you are looking at the ABD, okay, so ABD, it is not a closed frequent. ABD is not a closed. Here the same support as ABD. Okay, for example AD, if we are considering the AD is a frequent item set but has the same support as the ABD, and that's why AD is not closed, because here the support count is matching. So these things we have to keep in mind whenever we are calculating the closed item set and super item sets. So what we can say after the end of this, that the frequent item sets, they are a maximal frequent item sets belongs to the closed frequent and they belongs to the frequent item set. So this is what the thing that we can keep in mind, that the maximal frequent will be a closed frequent item set and it will be a frequent item set. So if I want to find out the example of finding the frequent item set, so and this example is given, then here we can see that the 5 transactions are given, and these are what the transaction we are having. So they are provided with the support count, minimum support count, that is 3, and what the relation we are holding, that frequent will be closed, maximal frequent will be closed, and then it will be frequent. So you can see that maximal frequent will be a closed and closed frequent will be a will belongs to the frequent item set. So this relation we have to hold over here. So now if we want to consider the data set given, so if I will calculate the one frequent means only for a single item set, one item set. So how many terms are there? A, B, C and D. So A occurs 1, 2, 3 times. B occurs 1, 2, 3 and 4 times. C occurs 1, 2, 3 and 4 times. And what about D? 1, 2, 3, 4 and 5. So this I will call it as a one frequent. It occurs only at a single time. So I will call it as a one frequent. What is the two frequent now? Two frequent means we have to take the combination of two, AB, AC, AD, BC, BD and CD. The meaning of DC and CD are same. So we are considering only once. So if I am talking about the AB, so how many times it occurring? AB, no AB, no AB. Here 1 and here 2. So 2 times AB is occurring. What about AC? 1, 2 and 3 times. What about AD? 1, 2 and 3 times. What about BC? 1, 2, 3 times. What about BD? 1, 2, 3, 4 times. What about CD? 1, 2, 3, 4 times. So in this way I have calculated the two frequent. If 3 frequent, then we have to take the combination of 3, ABC, ABD, ACD, ABCD. So these are the combination. What about ABC? 1 and 2 times. ABD 1, 2 times. ACD 1, 2 and 3 times. What about BCD? 1, 2 and 3 times. So this is what the 3 frequent. What is the 4 frequent? A, B, C, D. How many times it is occurring? 1 and 2 times. So this is what the frequent count I have calculated. Now I want to find out whether they are maximal or not. So we are not drawing the diagram, but we can mention in the words also. Let's get it open. Yeah. So here we can see according to what I have found out, 1 frequent, 2 frequent and likewise. Okay, whatever we have calculated. Now we will check whether they are closed or not. Whether they are closed or not, that we are going to find out. So A is a frequent. A is equal to 3, it is frequent because the minimum support count is 3. Okay, minimum support count is given in question, that is 3. So I will say A is a frequent, B is also frequent, C is also frequent and D is also frequent. Means all of these are frequent. What about their closed? Then for closed we have to check their immediate superset. As it is 1 frequent, so their immediate supersets will be only 2 frequent, not the 3 frequent. So I will check for the 2 frequent. What are the superset of A, AB, AC and AD? These are the 3 supersets. So if any one of them will have their count is equal to this 3, then we can't say that A is a closed figure. So AB is having its count less than A. Okay. AC, we can't consider AB because AB is not frequent. Why? Because their count is 2 and 2 is less than the minimum support given, that is 3. So we can't say that AB is frequent. We can't say AB is frequent, so we have to ignore AB. We have to ignore AB, means we are not going to mark AB as a blue circle. Okay. Then what about AC? AC is having count 3. Yes, AC is a frequent. What about AD? AD is also frequent. Whether now we have to find out whether A is closed or not. So AC is having its support count same as equal to A. So we can't say that A is a closed figure. Why? Because AC is having the same support count as A, and that's why it is not closed. What about B? B is having their superset as a BC, BD and CD. Okay, what is the value of B? 4. Means its superset should not have the value 4. Whether it is happening? Yes, its superset BD, CD is having its value 4, and that's why B is also not a closed. What about C? C's supersets are AC, BC and CD. AC is having 3, BC is having 3 and CD is having 4. What is the value of C? 4. Yes, CD is having 4, and due to this CD, the C is not a closed figure. Okay, what about D? D is having value 5. What are its superset? AD, BD and CD. What is the value of AD? 3, BD is 4 and CD is 4. Yes, all of them are less than its support count 5. So that's why I will say that D is closed item set, because its supersets are not matching with this 5. Okay, the supersets are not having the value 5, and therefore D is my closed item set. Same way you can find out for this too frequent, for the calculating whether these two frequents are closed or not. For that you have to find out its immediate superset, and its immediate supersets are 3. For example, if I want, now we have ignored the AB because it is not frequent, because its value 2 is less than the minimum support. If I am talking about C, AC, so what are the supersets of AC? ABC, ACD. These are the two supersets. Okay, ABC is again having value 2, so that's why we can't consider it as a frequent item set, so we just ignore, because we are not going to mark it as a blue, so we are not going to consider this. Then what are the next? ACD. ACD is having its count as a 3. What is the count of AC? 3. As the count is matching 3 and 3, that's why the AC is also not a closed figure. AC is also not a closed figure. If I want to talk about AD, what are the supersets of AD? ABD, ACD. These are the two support sets. But ABD is having value 2, which is less than minimum support, so we are going to ignore the ABD. We will talk about the ACD. ACD is having its support count 3. What are the support count of AD? 3. Again it is matching, that's why I will say that AD is also not closed. We are directly jump towards the BD. BD is having its support count 4. What are its supersets for a BD? ABD and BCD. We are going to ignore ABD because it is not a frequent. We will directly talk about the BCD. BCD is having support count 3, and what is the support count of BD? 4. So it is not matching, so that's why we can say that the BD is closed. BD is what? Closed. So in this way you have to calculate this thing. And how you are going to calculate the maximal frequent? If we are directly talking about this ACD, so ACD is a maximal frequent. Why? Because whatever the ABCD, that is not a frequent. ABCD is not a frequent because its value is 2, and we can't say because its value is 2 and it is less than minimum support, so ABD is not frequent, and the ACD is having its immediate super subset, that is superset as a ABCD, which is non-frequent, which is not a frequent, and that's why ACD is maximal frequent. Same for BCD. BCD is having their superset ABCD, which is not frequent, so I will mark it as a maximal frequent. So in this way you have to calculate this. If you are write down this in the terms of that lattice pattern, then it will be very easy to find out whether it is superset or not. If you are finding in a such a way, it is absolutely okay to find in this way also. Okay, so in this way we are going to find out our superset and the that frequent item set and the closed item set. With that we can also find out the maximal frequent. So this is the thing that we have learned today about the support count and all things. So we are going to stop here today with this two example of frequent item sets and the closed item set, for with that also the maximal frequent items. So here we will stop today. Thank you all of you.